I too would like to express my appreciation, Danny, for an opportunity to speak today and hear a tremendous series of speakers, which has really helped me get my mind around the challenges that face Texas and our nation, because Texas is a vital part of that in the economy. And coming here back to the university kind of reminds me of my alma mater. Grew up in California, Southern California in particular, University of California at Irvine, and the home of the fighting anteater. Here. Yeah, and they say that when you back one of these creatures into a corner, their claws come out and their tails hit you, and it could be very, very severe. But this is pertinent because this weekend I was looking at a alumni newsletter from the engineering school. And there was a bunch of faculty and students, and they were all given the Texas Longhorn high sign. And I thought, wow, what a coincidence. I'm going down to Austin, and there it is, one of the greatest brand images known in this country, right? But then upon further inspection, I realized they were actually signaling this, which actually resembles an anteater, right? Right? And so I guess, imitation's the greatest form of flattery, right? So I think they're trying to catch on here. But upon even further inspection, just to make sure that I was politically correct, I went online, and I found this disclaimer, right? Which basically says, this is actually a llama, right? And this is an anteater when you curl the thumb under, right? And you probably can't see this, but up at the top it says, how do you do the UCI Irvine anteater? Rip 'em. Rip 'em? An anteater? I just can't buy into that. So, needless to say, the brand image is not threatened here at the University of Texas by the Irvine anteater. So, what I want to talk about today, and then I don't want to cover a lot of ground that's been already presented, but talk to you a little bit about industrial water reuse and what we've seen applied to date, and touch upon what we think the future holds and where some of our R&D dollars are going. So Texas, we're here today because we really, Todd and I and others, really enjoy the field of water treatment. It allows us to apply fiscal and environmental stewardship in the work we do. And we're also here because GE has a big vested interest in the state of Texas with over 9,500 employees. So we want to make this community sustainable for those fellow associates, whether it be healthcare, aviation, GE water, power, oil, and gas, as Dr. Freeman indicated earlier with our investment here. So we are committed to Texas. In terms of industrial reuse, you've seen similar slides today, but I wanted you to understand that the use of industrial water around the world is nowhere near what it is here in North America, but it's growing. The vast majority of our advanced membrane systems on reuse water are overseas, especially in the oil and gas industry. Okay? And this is important when we talk later about economics. Okay? You've seen this slide before, and just a little different variation from the 2012 report. But what is water reuse? Conventional technology, whether it be clarification, activated sludge, mixed liquor, aeration, treatment for organics, and conventional filtration, media filtration, would discharge directly to your river, right? But reuse looks to do several things. Number one, use advanced technology, right, to recover some of those valuable resources. For instance, carbon can be an energy source, especially in food processing, where the biological oxygen demand levels are very, very high. You can capture that and produce gas through an anaerobic treatment process, right? As well as inorganic salts. My associate Todd touched on this earlier. Can we convert those salts to a usable byproduct, right? And then reuse options. Can you expand the number of reuse options beyond agriculture and recharge, right? Indirect potable use. And in some parts of the world, they're looking at direct potable reuse with advanced technologies. So the technology itself, we touched on these topics today, whether it be a membrane-based system or a thermal-based system. just keep in mind that you have a concentrate stream you need to manage, right? Whether it's deep well injection, evaporation pond, or using thermal evaporation, right? But a lot of our research and development is in creating those salts. It's in creating membranes that are less susceptible to fouling, right? Which includes the management of dissolved inorganics and how you do that, as well as hot oil, produced water that comes back, say, in the oil sands of Alberta. How do you recover that heat and maintain it? Is it with ceramic membranes, or is it more conventional membranes? And then the cost associated with these different technologies, right? They could be standalone technologies or a combination of processes. Ultrafiltration could be used for direct filtration of surface waters for drinking water purposes. It could be used for tertiary filtration for wastewater, either for direct discharge, especially if you have a low nutrient discharge limit, or if you want to feed it to downstream desalination technologies, you would use ultrafiltration. If you want to combine that with a membrane bioreactor, or as a membrane bioreactor, you can enhance the organic breakdown of solids and produce a pristine effluent, again, for additional feed to downstream processes. Reverse osmosis, electrodeionization, thermal, they're all available technologies, but they come with a certain CapEx and OpEx costs, right? And you have to look at the application to determine if it's justifiable compared to all your other alternatives. But the good news is we have a lot of data now. These advanced membrane systems have been on wastewater of multiple types for 10, 15 years. So we can help calculate CapEx, OpEx costs for comparison purposes to see if it's a viable alternative. On the left-hand side, you see the more readily usable municipal wastewaters, and many industries use municipal wastewater because of its proximity to the source, its predictability, its availability, and as well as its treatability, right? The Palo Verde Nuclear Power Plant just signed an extended agreement for the municipal wastewater from the city of Phoenix because they wanted to assure that would be an available water source. Right? I mentioned earlier, risk profiling, right? Can I maintain a sustainable business if I don't have secure water sources? So this is changing the value of water, municipal as well as industrial wastewater, but industrial comes with a higher cost, more processes, more complexity as well, and the need for operator skill as well. Just some examples of cases. One industry that's leading this are our beverage soda bottlers, water bottlers, such as Coca-Cola, PepsiCo, Nestle, Schweppes, right? They're trying to squeeze every ounce of water they can for a given product unit that they're delivering, right? They will look at an entire process stream, RO. They'll put a concentrate RO on the first pass RO concentrate stream, and then they'll take that water, treat it with a membrane bioreactor, and feed it for non-product uses, cooling towers, boilers, wash water, etc., right, to increase the recovery of their product. This is important to them as they develop bottling plants throughout the world. Their approach is they go and they look at the watershed, just as we should when we're planning regional water plants. You've got to look at the entire watershed to make sure that you're not creating an adverse impact, right, upstream into the water source as well as downstream in the discharge. Okay, they do also on the wastewater side. This is a Coca-Cola plant in Puerto Rico. Notice the COD content, the biological content that can be converted to renewable energy source and fired in a boiler or a gas engine. And to give equal time, PepsiCo, Frito-Lay, Casa Grande, where they're recovering over 80% of the water. Oil and gas upstream, we touched on this earlier. Several speakers addressed this, but there are systems operating that have NPDES permits to the upper Colorado River, and they've discharged over 5 million barrels since they started operation in 2006. Again, using multiple technologies to do that. The same in Alberta. We have over 30 thermal evaporators now treating produced water and heavy oil recovery on SAGD, which stands for steam-assisted gravity drain. Right? And it's become the preferred method of managing water and getting it permitted rather quickly. Downstream, we have several, dozen plants now around the world. This is the oldest. It goes back to early 2001. Again, 6.8 MGD of UF tertiary treatment followed by RO. And this follows a biological treatment process, which is very typical in a refinery, especially here in North America in the state of Texas, where they treat the water with RO and they recycle back several million gallons a day. And again, when you're in a situation like Mexico City, and you're paying $6.50 to $7 per 1,000 gallons, right, this becomes a viable alternative. Automotive, several automobile plants as well, highly oily content waste, as well as high organics that could be recovered as well. Semiconductor, the facility in Singapore. Singapore does a lot of seawater desalination rather than barging water in from Malaysia. And they recycle their water using UF-RO advanced oxidation for semiconductor makeup water for direct potable reuse as well. So the technology is available to do this. And then power, there's several cases of municipal reuse, not only across North America, but here in the state of Texas. And there are some challenges, and there's an ASME WEF committee that's looking at reuse in utilities. If anyone's interested in what that committee is all about, let me know. I'd be happy to talk to you at the reception later. And then irrigation. I'd be remiss if I didn't tell you that a couple of my two favorite agriculture products involve vineyards and golf courses. So this is in the lower Napa Valley, and again, even though there's a lot of water that falls in Northern California, they still have a need for reuse as well. So in terms of technology, I think we've touched on that today, right? Try to minimize the fouling of pretreatment technologies that go to downstream desalination, trying to improve the energy demand of some of these treatment processes with ultra-low pressure RO membranes, and trying to reduce the amount of energy it takes to break down organics, right? We now have, we're looking at anaerobic MBR treatment, right, to minimize the amount of power required to break down organics that you would see in a typical aeration process, right? And then policy, you touched on it all today, and I was very grateful for that, especially looking at each water basin and all the stakeholders in it, and considering everyone in the equation. So I applaud the speakers today that addressed that. And then finally, thank you for being here today. If nothing else, if you could just make other people you know aware of water and how important it is to all of us, I would appreciate that. So thank you again.